Okay, so hello and welcome back. So there are some basic concepts that we have learned in, I suppose, in the previous chapters that we have talked about trigonometry. So let's go through them one by one. So the basic concepts that we had, and let's see what they are. So first of all, these are some definitions of basically trigonometric functions. Some definitions of trigonometric functions. So first of all, we have the sine function, and you know that the sine function, in the case of the sine function, we have sine function. We have the sine function, and this sine function is basically, we have the sine, and the domain of the function is the set of real numbers, and the codomain of the function is defined as basically is defined as the interval -1 to 1, right? So that the codomain is actually not the set of real numbers, as we can see here. Is the interval -1 to 1, and what that means is that you have well, let's actually do the graph of these functions at least once to see what they look like. So you know that basically the function is basically, of course, a periodic function, and basically the upper limit of this function is the upper limit of the codomain of the function is 1. The lower limit is -1. So this is 1 and -1. And then the domain of the function is the set of real numbers, meaning that you have, if you think about this as in terms of a unit circle, then you have this circle. You have a circle over here. Now I'm going to just simply draw a circle like this, and this is 0. This is pi by 2 in radians. This is pi. This is basically 3 pi by 2, and this is 2 pi, all in radians. Now you know that basically the sine of the sine 0 is equal to 0. So if you were to do a table over here, you could say that sine, this is theta, for example, and this is sine theta. So if theta is equal to 0 radians, then sine 0 is equal to 0. Then pi by 2, sine of pi by 2 is equal to 1. Sine of pi by 2 is equal to 1. Sine of pi is equal to 0 again. Sine of pi is equal to 0 again. Sine of 3 pi by 2 is equal to -1. And the sine of 2 pi is again the same thing as 0, which is equal to 0. And basically you will get basically all of these points, which is basically 0, 0, 0, and then you have 0, you have pi by 2, you have pi, you have 3 pi by 2, you have 2 pi. And then if you go in the other direction, you will have again, you can go in this direction, which is basically where this angle becomes -pi by 2, -pi, -3 pi by 2, -2 pi, and you can just go around the circle over and over again. Which means that this is negative pi by 2, this is basically negative pi, this is, for example, negative 3 pi by 2, and this is, for example, negative 2 pi. And so by the same logic, this is pi by 2, this is pi, this is 3 pi by 2, and this is pi. I'm sorry, 2 pi. Now, as you can see, basically sine of pi by 2 is equal to 1. Sine of pi is equal to 0. Sine of 3 pi by 2 is equal to negative 1, right here. And sine of 2 pi is equal to 0. If you go in the other direction, sine of basically negative pi by 2 is the same thing as the sine of would be this angle over here. It would be basically this angle over here, right? And meaning that you have to move in this direction, that would be negative pi by 2. And so what that means is that the sine of negative pi by 2 is actually the same thing as the sine of 3 pi by 2, which is negative 1. So you can say that the sine of negative pi by 2, if I were to extend this table a little bit, negative pi by 2 is the same thing as sine of 3 pi by 2, and the reason is that the angles, as you can see, are coterminal, meaning that the angle 3 pi by 2 and negative pi by 2, the angles are coterminal. And of course, it doesn't matter in how many ways you go around the circle, in which direction. If two angles are coterminal, then you can say that all the different trigonometric ratios related to those two angles are going to be the same, meaning that the sine of those two angles are going to be the same, the cos of those two angles are going to be the same, the tan, cot, secant, cosecant, and so on, everything would be the same, because they are practically the same angles, of course. So what that means is that now we are talking about the sine of negative pi by 2. It becomes the sine of 3 pi by 2, which is equal to negative 1. Then if you move in the same direction a little bit more to get here, then you have the sine of basically negative pi. Negative pi would be the sine of pi, and the sine of pi is equal to 0. Sine of pi, negative pi, would be the sine of pi, which is equal to 0. And then you can move a little bit further in the circle, and then you would get to this point over here, which is negative 3 pi by 2. Negative 3 pi by 2. Negative 3 pi by 2 is the same thing as sine of pi by 2, which is equal to 1, of course. You see that sine of pi by 2 is equal to 1. So negative 3 pi by 2 is equal to 1. And then if you go all around the circle to get here, you're essentially at the sine of 0 or 2 pi, which is of course equal to 0. Either 0 or 2 pi, the sine is 0. And so you have negative 2 pi. The sine of negative 2 pi is equal to 0. Which means that you will get to, you will have negative pi by 2 is negative 1. The sine of negative pi by 2 is equal to negative 1. The sine of negative pi is equal to 0. Negative pi is equal to 0. The sine of negative 3 pi by 2 is equal to 1. Negative pi by 2 is equal to 1. The sine of negative 2 pi is equal to 0. And then you will get this periodic function that keeps doing the same thing over and over again, right? So that is your function. Now, as you can see, of course, the domain of the function, and you can just keep going in this direction and this direction. There is no restriction on the domain of the function. But as you can see, the domain of the function is a set of real numbers, all the set of real numbers, all the way up to plus infinity and minus infinity. But the range of, or basically the codomain of the function goes from -1 to +1, and that's basically that's all that the function can do. It oscillates between -1 and 1. So the codomain becomes -1 and 1, right? And of course you appreciate the fact that basically this is the codomain and not the range. This is not the range of the function, and this is the domain of the function, right? So that is basically that. Now the cos function, and now I didn't actually tell you why I suppose you already know all of those things, so I don't need to talk too much about this, but basically, for example, why the sine of 0, for example, is 0, and why the sine of pi by 2 is 1 and pi is 0, and so on and so forth. Let me talk about this only in the case of one of the functions, and then hopefully you will be able to get the hang of it for the other functions, because essentially there is only two basic functions that we have in trigonometry. In trigonometry we have the sine function, we have the cos function, we have the tan function, we have the cot function, we have the secant function, and we have the cosecant function, right? So these functions, we have them in trigonometry. Now, tan of x is the same thing as sine x by cos x. So it's nothing, it doesn't have any sort of, you could say that it doesn't have any sort of identity of itself. It's dependent upon two other trigonometric ratios, namely sine and cos. And then you have the cot, which is again the same story, meaning that cos is the reciprocal of tan, and so you can write this as cos of x over the sine of x. So this doesn't have any identity of itself either. It's dependent upon these two functions. So you can just simply say that tan and cot are not new functions. Secant x is basically nothing but basically the reciprocal of cos, which means that you can write this as 1 over cos of x. So this is again dependent upon cos, and so no new function. And cosecant of x is a function which is the reciprocal of sine, so you can write this as 1 over sine x, which means that this doesn't have any identity of itself, so to say, and it's just another way of saying, it's just another way of expressing the sine function. The sine function is basically the kind of function that you need to understand. Also, the cos function is the kind of function that you need to understand, because these have their own identity and they have their own definition. Other than that, all of these functions are defined in terms of sine and cos. So now, in order to understand these two, what I'm going to do is that I'm going to talk about, for example, the sine function, and say that, and basically we will go through a table of values of the sine function and see why actually is it so that basically we say that, for example, the sine of theta when theta is equal to 0 is equal to 0 and pi by 2 is 1, and so on and so forth. So that and then you can do the same thing yourself for cos, and then the other functions as we discussed are just like dependencies of these two functions, right? So now let's do just that. Talk about how I got these values. Okay, so basically it's actually a very simple idea. The whole concept of trigonometry. Of course, there is two sides to trigonometry. So basically the whole idea of trigonometry is just this. You could say that it's a simple triangle, right? So you have a simple triangle, and suppose that you have a triangle like this, and of course in trigonometry we always start with a right triangle, and this is the 90-degree angle. So we have basically in a right triangle there is a longest side in the triangle, which is called the hypotenuse. Now there is basically another side over here which is called, sometimes there is two terms that you can use here for either of these two sides aside from the hypotenuse, and that is basically adjacent and opposite. Now if you understand basically these simple facts about the triangle, you essentially understand the whole concept of trigonometry. So you know that in a right triangle you have the hypotenuse, you have basically you have this side and this side of the triangle. Now if I call this angle theta, then relative to theta, one of these sides is going to be opposite theta, one of these sides is going to be adjacent to theta, and the third side is of course going to remain hypotenuse, because whatever you do, the hypotenuse remains hypotenuse, meaning that whether you take theta here or here, you have basically two possibilities. You can take theta here or here, right? If you take theta here, this side relative to theta, this side becomes opposite, and this side becomes adjacent. This is just so that we have some terminology to talk about these sides, otherwise this is just some terminology, of course, only. Now if you take your theta here, then this side is going to become the opposite, and this side is going to be adjacent, because then theta would be some angle over here, right? So far we have no problems. Now in this triangle there are a couple of things that have been defined, and these are just simple definitions. Now this whole story of ratios works based on all of the very wonderful things that happens in all of these ratios and proportions that remain that there are in triangles. And personally I find triangles one of the most fascinating things in the whole universe. I just like them so much that, whenever I was doing all of these geometry courses in class 6, 7, 8, and all of these books, of course those courses I've never published them anywhere, but I had so much fun with triangles, and I actually love them so much, because they are the most fascinating thing in the whole universe, at least to me. And there is all of these properties of triangles that, for example, all of these proportions and everything that remain the same, and there are different types of behavior and so on and so forth. Now, so basically you take the angle theta here, and this is opposite to theta, this is adjacent to theta. And now, based on all of the different, again, wonderful properties of these triangles, there are some ratios that mathematicians have defined in triangles, meaning that they have defined some, well, of course this goes back like 2,000 years at least, but at the end of the day, today we have a trigonometric ratio called sine. We have sine, and sine of theta is basically defined as basically the side which is opposite theta, which is basically the side, or the side length, actually I should say, the side length opposite theta. And then you have, in the denominator of this fraction, you have the hypotenuse. So you have the hypotenuse length. So you put the length of the hypotenuse in the denominator, meaning that you're simply taking the ratio of this side length, which is opposite theta, and the ratio of that side length to the side length of the hypotenuse. So that is simply sine of theta, which that's that. Now, in the same triangle, in the exact same situation, having the exact angle, having the same angle as theta, you have basically cos of theta. You have the cos of theta, which is basically the side length basically adjacent to theta, which is this side length here. You have the side length adjacent to theta, and then in the denominator again you have the same thing, the hypotenuse length. The hypotenuse length, right? So it works this way. And then of course you have, as we discussed before, you have, for example, you have, for example, the coded, another trigonometric ratio, for example, which is the cosecant of theta. Cosecant of theta is by definition the reciprocal of sine, which means 1 divided by sine theta. Which means that, for example, if I call this the side of the length opposite theta, if I call that A, for example, and if the hypotenuse length I call it H, for example, then this would be equal to 1 over sine theta. Sine theta is A by H, so this becomes H divided by A, meaning that the cosecant of theta in this case becomes basically the hypotenuse length divided by this length, which is the side length opposite theta, right? So you don't have to learn anything new here. It's just that basically you take the reciprocal of sine, and that becomes cosecant. We have also secant of theta, which is basically the reciprocal of, for example, cos theta, 1 divided by cos theta. And if I call this, for example, the side length adjacent to theta, if I call it B, and again the hypotenuse length, if I call it H, so that would be 1 over cos theta, which is B divided by H, which is equal to H divided by B, right? So it's very simple, not rocket science, of course, but there is one thing that of course you should know, and that is, when I was, about some 12-13 years ago, I went to India to go to college. And so back then I needed all of these concepts of trigonometry, mathematics, and so on, physics, and so on and so forth. And well, I mean, back at the time, I mean, never ever in my whole life did I ever have a background of mathematics or science for that matter, for different reasons. But then I wanted to learn all of these things, and I basically authentically wanted to really learn these things. But then I struggled so hard with learning these things, and I found the books impossible to understand. And then I got a couple of tutors in India. They taught me, they gave me private lessons in mathematics. But then again, I got to the same problem with the tutors. They don't, I mean, it's not about understanding mathematics, it's about passing your exams, which wasn't exactly the kind of thing I was after. So now I feel the need to actually talk about all of these things and make it, well, of course, there is a problem still that it's not easy to find people like me who really want to understand. People want to pass their exams and they want to get their degrees and so on and so forth. And of course, that's understandable in the world that we have today, but that's never been really me. I actually never wanted to get any degrees or anything. I wanted to understand, and the books were not so helpful back then, and then I had to do many different types of things to learn, and now I guess I want to share these so that if there is anybody in the world like me that wants to understand, that they have a way to do so without going through so much trouble that I had to go through. Now, so we have sine theta, cos theta, cosecant theta, secant theta. Then we have basically, for example, another trigonometric ratio that we have is the tan theta. Now, tan theta is by definition the same thing as, well, sine theta by cos theta. Sine theta by cos theta. So you can see that sine theta is a by h is equal to a by h, and cos theta is the same thing as b by h. So h and h you can cancel out, it's a divided by b. So meaning that you simply take for tan theta, you simply take a, which is the side length opposite theta, right? The side length opposite theta, and you divide it by the side length adjacent to theta, meaning that this side divided by this side would be the tan of theta. And of course, in coordinate geometry, you must remember that we define the slope of a line as tan of theta. That was, I mean, the angle theta that was constructed in that case, and that's basically the reason, meaning that it's just you can basically imagine that this is for example, a ramp, and what do you do in order to calculate the slope of a ramp? So this is the amount of rise, and this is the amount of run if you imagine that this is a ramp, right? So you call this rise, you call this run, and then if you take the ratio of rise to run, that gives you that's some way of expressing the slope of that ramp, right? If, for example, there is no rise, your rise is going to be 0, and so rise over run would be 0 over some run, for example, over some run, which is equal to 0, which means that then it's a flat surface. It doesn't have the ramp doesn't have any slope. And so basically tan of theta is again the same idea of calculating the slope of this ramp, because tan of theta is actually nothing but the slope of this the line which is the hypotenuse in this case. And so if you divide this rise over this run, you are going to get the tan of theta, which is incidentally of course also the slope of the line as well, right? And then there is the cot of theta, which is by definition cos of theta, which is not even that. You could even say that, well, you could say that the cot of theta is the same thing as the reciprocal of tan, meaning that 1 over tan theta. And what is tan theta? Sine theta by cos theta. Sine theta by cos theta. And what is one divided by this fraction? You will get the reciprocal of that, which is cos theta by sine theta, right? Which means that that means that basically cot of theta is the reciprocal of tan theta. That means that instead of a to b, you will get b to a. So as you can see, there is nothing really complicated about this triangle. If you understand the simple fact that basically sine of theta is this length opposite to theta divided by the hypotenuse, and also the cos of theta is basically this length, which is the adjacent divided by the hypotenuse, you already understand enough about you already understand a large part of trigonometry, because trigonometry is nothing but just a simple triangle. And then what we do is that because we are dealing with basically obtuse angles as well, meaning angles larger than 90 degrees, then what we do is that we take the same triangle and then we put it inside a circle so that we can move all around the circle, so that we can take the different trigonometric ratios of different angles. For example, 210 degrees, right? That gets out of a triangle. Even 3 angles in a triangle would be 180 degrees. But with that circle, we have the possibility to find the trigonometric ratios of even 210 degrees and 270 degrees, 280 degrees, 360 degrees, even 1200 degrees, meaning 1200 degrees. So what we do basically the way that we define this circle is that basically we draw the circle this way, right? So we have a circle like this. Of course, it would have been better if I had created the center here, and then oops. No. Now let's imagine that. Okay. I apologize for. Now let's just assume that this is a circle. Of course, this is a circle, but I want to select the border, 1 pixel, and how do I put color into this? If I go to edit and fill with background color, and okay. I apologize for being a little bit clumsy. I haven't done this in a long time. I had forgotten. Okay, so so what we do basically is let's say that this is the center of the circle, and then we create 2 axes here, and we assume that this length, or which is the radius of the circle, is 1 unit. The radius is basically 1 unit. So when I take the radius of 1 unit, so I have simply a circle of radius 1 unit inscribed at the center of a coordinate system, and this is my x-axis, this is my y-axis, right? Now I take the same triangle that we had here. I take the same triangle and put it in and here I have basically 4 quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. That is quadrant. So I take the same triangle and put it in the first quadrant here. Right, so I create the same triangle here. Now this angle here becomes my theta. So now what I can, again, the same rules apply, meaning that, for example, sine of theta is this length divided by the hypotenuse, which is 1. So in this circle, I don't have to worry about the length of the hypotenuse because it's already 1, at least as long as sine and cos are concerned. Then I have basically, then I can calculate the cos of theta, which is basically this length, the adjacent side to the hypotenuse, which is 1. And so for example, for the sine and cos of theta, for sine theta, we say that basically it is the side which is the opposite, meaning the side that is opposite to the theta to the hypotenuse. And well, so this is a length, right? This is a length, and this length is just simply 1. That means that the sine of theta actually is this length, right? Is this length, and that is basically this length over here. This length over here, which you can read off of the y-axis. So that this length, starting from here all the way up to here, this length is nothing but the sine of theta, because this is the length of this the side which is opposite theta, divided by the hypotenuse. Hypotenuse is equal to 1. So then the length, which is basically the opposite side of theta, becomes basically this length here, and that is basically sine theta. Now cos of theta is basically, as we argued before, it's equal to the adjacent side to the hypotenuse side. So the adjacent side is basically this length over here, right? Is this basically this length over here, and so this length, if you divide it by the hypotenuse, your hypotenuse is already 1. So you can just simply think about the adjacent side, and then this length over here becomes the cos of theta, right? So now if I think of this point on the circle, then I can say that basically the x-coordinate, as you can see, this is the x-coordinate of this point, and the x-coordinate of this point becomes cos of theta, and the y-coordinate of this point, as you can see, is the sine of theta. And of course that applies to any angle that you have all around the circle. If you, for example, if you have some angle like this, whatever that is, I don't know, but then this point on the circle, this becomes, again, the coordinates of this point become cos theta, comma sine theta, right? And so you can just keep moving all around the circle, and then whatever sort of angle that you have, this circle is going to provide you with the trigonometric ratios cos and sine of these angles. Very simple, right? Now, so this way you can find the trigonometric ratios of these angles. And now let's basically go back and find the trigonometric ratios of, for example, 0 for the sine function, and we have to go all around the circle and find the trigonometric ratios of the sine function. Okay, so now about basically the different trigonometric ratios of, for example, sine, right? So you want to know what is, for example, suppose that you have this unit circle. I'm going to attempt to draw another circle here. Let's see how that was. I don't actually remember. Let's see. Okay. So if you have a circle over here, and let's say that you have the circle here, and then I'm going to select the border, and then what was that? Shift Control, I think this thing, and then okay. And then if I have a unit circle here, so what we said was that basically if this is your unit circle, suppose that the radius of this circle is 1, and if this is x and y, now you can see that basically an angle, we need to go for these angles as 0, basically pi by 2, and this is pi, and this is 3 pi by 2, and this is 2 pi. And if you want to do them in basically in degrees, that would be 0 and 90 degrees and 180 degrees and basically 270 degrees, and you have 360 degrees, right? Now, what happens is that this is 180 degrees. Now, what happens is that we said that if you have a excuse me, if you have some angle over here, let's say that you have this angle over here in this circle, we said that this point on the circle becomes basically cos theta sine theta, right? The coordinates of this point becomes cos theta and sine theta, meaning that you always read the sine theta off of the vertical axis, and cos theta you always read it off of the horizontal axis. So as you can see, as I'm moving, if you imagine that this point we're moving along this circle, meaning that you take this point from here and just keep moving it along the perimeter of the circle, or around the circumference of the circle, you could imagine that there would be some angle here, some central angle here that would keep, I mean, that angle would keep increasing and increasing, and when you got here, it would be a 90-degree angle, right? And then you could just keep going, you would get a 180-degree angle, you could just keep going, you would get a 270-degree and 360 degrees angle. So what that means is that basically I could start from here, and and then as you can see, as I'm increasing the magnitude of this angle, basically this height is increasing on the unit circle, meaning that in the beginning the height is 0, then the height is basically this much, and the height goes over here, becomes this much, and then the angle goes over here, the height becomes this much, and so on and so on until you get here. And so the height over here is maximum, which is equal to 1 unit. And then once you keep increasing the measure of your angle, this height will keep decreasing and decreasing and decreasing until you get to 0. And then the height will start, once you keep increasing the measure of your angle, the height will keep basically increasing in the other direction, which is denoted by a negative number, right? Which is denoted by a negative number, which means that, for example, you could just keep going in this direction, and when you got, if your angle was some angle like this, for example, then the height would be this height over here, measured from here all the way up to here. And that would be, for example, something like 0.7 or 0.6, 0.65, 0.7. But this time this would be negative 0.7. Because down here everything is negative. Up here everything is positive. And then you could just keep going until you got here, in which case the height would be the maximum in the other direction, which means that then, for example, for 270 degrees, which is 3 pi by 2, then the height would be negative 1. And then if you still kept going, the height would decrease and decrease and decrease. Actually, it would be a much larger value, because you would be getting closer and closer to 0, but the magnitude, the absolute value of the number would decrease and decrease and decrease until you got here, in which case you would again get to 0, right? And then you can just keep going around the circle, and then the same thing happens, which is basically this behavior that we saw over here. You see over here, you start from 0, and you get to 1, you get to 0, you get to negative 1, you get to 0, again you get to 1, you get to 0, and so on and so forth, right? Which means that for 0 degrees, of course, the height is 0, right? So you can say that the sine of 0 degrees is equal to 0. When you get to 90 degrees, then of course you're over here and the height is maximum, so it's positive 1. When you get to 180 degrees, which is right here, so again the height has gone to 0, so that means that the sine of 180 degrees is equal to 0. When you go down here, you get to 270 degrees, it's maximum in the other direction, which means that it's negative 1. The sine of 270 degrees, it's negative 1. And then when again you get to over here, which is 360 degrees, the height has again gone to 0, which means that you can say that the sine of 360 degrees is equal to 0. And that's basically how you calculate the sine of all of these angles. Now by the same logic and using the same principles, you can of course calculate the cos of any angle that you want. For example, when you say the cos of 0 degrees, so you can see that the height is this time read off of the horizontal axis, or the horizontal axis actually, because it's only one axis. So meaning that at 0 degrees, basically the height is all the way up to here, so that means that it's a positive 1. So that means that cos of 0 is equal to 1, right? The cos of 0 is equal to, of course, 1. And for example, using a calculator, you can say that the cos of 0 degrees is equal to 1. Okay? and then you can just keep going. As you can see, as I increase the magnitude of or the value of this angle, if I just make it a greater and greater angle, you can see that for example I would keep moving this point along the circle, and I would get to, for example, this point. And then if I read this distance off of the horizontal axis, I would be reading this point off of the horizontal axis, which is something like, for example, 0.8, 0.7, and that would be some angle like, for example, 30 degrees, 40 degrees, right? 35 degrees. And so I can say that, for example, of course not like an exact value, but I can say that, for example, the cos of 35 degrees is something about, for example, 0.8. Now we can check that, of course, meaning that I can write the cos of 35 degrees. As you can see, it's 0.8. You can very easily tell these things based on this unit circle. And of course, it's a magical circle because you can do a whole different types of things using this circle, but I'm not, at this point, at least I cannot talk about all of these things because I would only probably confuse you. But I'm sure that, I'm going to, of course, hopefully do a whole, basically all of the chapters on trigonometry, and then over there, once I'm talking about trigonometry, I will be talking about these things over there as well. And you can see that, so I can basically keep moving this point along the circle. For example, as I got here, now then basically I would have an angle like this, right? So this angle would be this, and this angle, I would read it off of the horizontal axis. It would be this distance. This is about half of the distance between the center of the coordinate system and this point, which is 1. So then this is about, for example, 50 degrees or so. And then I could say that the cos of 50 degrees is about 0.5. And then you can just keep going until you get here. When you get here, you see that this distance is actually 0 because there is no movement to the right, there is no movement to the left. The line is just simply perpendicular to the horizontal axis, and it's basically drawn from the center of the coordinate axis. There is no moving to the right, no moving to the left. The height, the length along the horizontal axis is actually 0, which means that you can say that, for example, the cos of 90 degrees is actually equal to 0. And as you just keep going along this circle, you can see that then on the other side, these lengths become negative, meaning that, for example, this angle, if you say that it's 120 degrees, then the cos of 120 degrees would be something about negative 0.3 or so. And you can just keep going until you get to 180 degrees. When you get here, the line has already moved to the maximum in the other direction, and so you would be measuring this length along the x-axis, which is equal to -1, right? So then the cos of 180 degrees is therefore equal to -1. You can just keep going, and you can see that basically again the value of the cos is increasing because it's a negative number, and the magnitude, the absolute value of the number is decreasing, is meaning that here over here you have -1 and then you have -0.8, so that the number is actually getting bigger and bigger as you go in this direction, right? So, but the absolute value of the number is decreasing, of course, although it's a negative number, right? So you can just keep going in this direction until you get here, And when you get here, the length of that line along the x-axis is 0, which means that the cos of, for example, 270 degrees is equal to 0. And by the same logic, you can just keep going until you get here, which basically means that you've gotten to 360 degrees, and that is equal to this length along the x-axis, which is equal to positive 1, which is, of course, equal to the cos of 0 degrees, right? The cos of 0 degrees. And based on these values, then I have calculated, then I have written all of these values over here, and then based on that, I have drawn this graph of the function f of x is equal to sine x. So that is basically about sine. Now in the next video, we will talk a little bit about the cos function and the rest of the functions that we have here. So I'll see you in the next video, and thank you.